All right. Hi, everyone. My name is Nicolas Hoford.
And I'm John Hoford.
And so we're going to talk about ConstraintLayout 2, which after numerous alpha releases, we are hoping is soon to be in beta. All right, so why ConstraintLayout? Well, if we go back to ConstraintLayout 1, what is it that we try to achieve with it? Essentially, the idea was to make creating a UI faster, easier, take your pick. How we wanted to do that, there was a couple of main ideas. One was trying to separate, to decouple the view hierarchies and the informations on how you lay out those views. And that's a very important aspect of constraint layouts. Like this idea that essentially your views, it's all going to be flat. You are not going to have a hierarchy because all the constraints information is essentially sitting aside. Why do we want that? There's a couple of reasons about performances and stuff, but to me, the main reason and the more useful reason is that you can then encapsulate all the layout rules and swap them with another set of rules, and that's what we call constraint set. That comes in very handy in today's user interfaces where you want your user interface to react to state changes, to animate to a different representation, etc. The other aspect, as written here, is like we want it to be released as a support library to more easily update, which was kind of new at the time. And we built it on top of a constraint linear solver that's very powerful, and we explicitly do not expose that to you developers. But that allows us to add new features much faster. And finally, we built it very tightly coupled with the UI builder in Studio. And again, the idea was, to basically provide you an environment where it's faster to create your UI. Now, when to use constraint layouts? Because we had some feedbacks over the years. Some people, took it as, hey, you know what? Constraint layouts, use it all the time. There's no caveat. Well, not quite, right? Like the way we thought about it is more like constraint layout should be used if you have a layout that previously would have resulted in a lot of nested linear layouts, for instance. Or you should use it if you find it more compelling and more easy to create your UI with. Or if you need some of the more powerful ways that constraint layout can react to your layout, to your screen changes and stuff like that. But we never really said, hey, never use linear layout, specifically when you have very, very simple stuff. Because, of course, constraint layout has a little more setup to do. So if all you have is a linear layout, by all means, use linear layout. That's perfectly OK. Of course, if you don't have a linear layout, but you have like 10 linear layouts nested all together, well, maybe you should use constraint layout. But just keep that in mind. The general idea, I would say, is our role as working on the Android team is really to provide you with tools to make your life easier. And we are not mandating anything, OK, so constraint layout 2, why did we start with that? Well, we wanted to build upon constraint layout 1, specifically in emphasizing more flexibility. And constraint layout is very flexible, but we kind of wanted to bring back that flexibility to you, to the developers. And we did that in a couple of ways, mostly with the helpers and some things we are going to cover. We also did quite a lot of work on optimizing. We're not going to cover that in many details, but essentially constraint layout 2 is going to be quite a lot faster than constraint layout 1. And of course, MotionLayout, which is a big component in the constraint layout 2 library, which allows you to, to handle motion. And of course, similarly as for constraint layout 1, there's a big focus on supporting UI builders, motion editor, design tooling, and etc.
So I'm sorry to say that we will not be talking a lot about Motion Editor today because we put the development a bit on hold to work on Project Marble, if you've heard of it, essentially improving the base infrastructure of the editor. Essentially, Motion Editor will drive the editor really hard. It's doing a lot of computation in real time on your system. it needed to have Project Marble in front of it. And so right after I.O., we will start working on it again, and you'll start to see some alpha releases soon after that.
Yeah, so we have not forgotten about it. Please do try the latest version of Android Studio. It should be much nicer in general, we hope. And we'll try to have a release of the motion editor in an upcoming alpha of Studio. Okay, let me cover very briefly the architecture of the library. It will be a bit easier to explain some stuff afterward. So as I said, we are starting from this linear solver, very general, pretty optimized, but it can be improved a lot by defining this constraint model. So, and that constraint model is what we expose to you. It's essentially the language you are using to describe the rules for your layout. What's nice is we can take this model and optimize it at that level, in addition to whatever optimization we do in the linear solver itself. And in fact, in a lot of situations, we can even bypass the linear solver. So it's, all in all, that's what will make ConstraintLayout 2 quite a lot faster. On top of that, we built helpers objects and virtual layouts that you can think about it as bringing some of the capabilities of the previous layouts to ConstraintLayout. We'll cover that a little more. And on top of all of that, all of those features, we have MotionLayout. So ConstraintLayouts, how many of you are using ConstraintLayout right now? Okay, pretty much everyone. So, so you should be familiar with the concepts we are using to describe a layout, the direct constraints, the relative constraints, circular constraints, all the stuff about dimensioning, ratio, etc. Change is very interesting. It's a way to apply group behavior in only one direction, in only one axis. And the helpers that you, at the very least, you should know about guidelines and barriers, but there are others. And we had a couple of concepts we introduced last year about decorators and virtual layouts. And finally, the constraint set, and I briefly touched about that, but it's this idea that we can actually encapsulate all those rules into one object, a constraint set. So helpers object. So it's something very specific to ConstraintLayout as a layout manager. It's this idea that you can have, in addition to whatever rules for your object, you can have other type of helper object that lets you create your UI in a faster way. And those helper objects do not result automatically in something visible to your screen. They are here to help you set up your screen. So the basic one is guideline that you can see here in the layout editor. We have barrier, which essentially is going to float depending on the positioning of the element it referenced. And for those helpers, we actually have some support in Android Studio. So if you have the component tree, you can basically just open them, drag elements to them, and that allows you to create those references. And so the general idea with a constraint helper is that it references views. It's important because it's not a view group where once an element is in a view group, that's it, it's in it. With a constraint helper, you can have multiple helpers referencing the same views. So that can be very flexible and can come in very handy. So you can think about it more as a system of tagging. Same thing with layers. And if you can tag objects like that, you can think about it as tagging them with a specific behavior or associating a specific behavior to specific views. As I said, this is the class constraint helper. It's actually public. You can create your own helpers. It has some support in Studio to manipulate them. And we think about it as a way of, if you have some specific behavior that you want to reuse, to package for yourself, you can do so. A common example is if you want to have a circular reveal, to have an animation, maybe not. Yes, a very, very famous effect. Well, we're not reinventing the wheel here. We are just using the ViewAnimationUtils circular reveal code, and we set it up in a constraint helper. So the code we're actually dealing with here is just this one. But what's nice is that once it's packaged into that constraint helper, I can use it in my XML file without adding any other code, and it's purely declarative, which is another important aspect of constraint layout and motion layout. We tried as much as possible to let you specify things completely declaratively, purely in XML, and you don't have to code stuff. We do offer some API so that you can do runtime behavior in code, but a lot of the stuff we provide you can do directly in XML. So decorator is another idea that can piggyback on this concept of helpers. And the idea is that, well, if I have a helper that can reference, that can get hold of some reference object, maybe I can do something with it graphically. Because a constraint helper actually, in reality, is a view. So you could do stuff. So here is a quick example. Let's say that I want to create a bottom panel. You can imagine having a bunch of image views like that. Well, you could create a chain to position them. Great. And here you could actually create a constraint helper that will build the chain for you, so that you don't have to set up the chain constraint manually. Let the helper do it. The helper is a view. Set the background. You can have that helper specify some color on those image views. But because, again, this is a perfectly first-class view, you can do more interesting behavior. So here I'm just saying, well, for the view that's selected, I'm going to apply this small animation and etc. And that's kind of the idea with the decorators is that you can do a specific visualization that is based on the positions of multiple views and not just one single view. That actually opens the door to some specific graphical effects that would be otherwise very difficult to do, because you would basically do it across hierarchies. But here, because we are at the same level for the hierarchies of the views, and you just reference those things, you can do a visualization that takes in account those different views. I'm not going to talk about virtual layout just now, but essentially you can think about it as a way to more easily create constraints for the views so that you don't have to do it by hand one by one.
So motion layout. The first question is, what is it for? There's two basic things you think about if you just need an animation. Just do it's good at setting up and doing animations. You can also use it to reflect state of your system. So you might have, I'm logged in, I'm not logged in, I want to reveal stuff. It's good at setting up different kinds of states of your UI, and that way can help. The big thing that it's good at is it's good at coordinating multiple components simultaneously. So you can have a dozen views and you're doing a bunch of things to them and they'll all animate together. The other thing it can do is drive custom views. So you can build your own view, you can have a set progress on it, and then you can drive it, or you can have any attributes and you can drive it with the motion layout. So what is it? It's basically a subclass of constraint layout. It gets constraints from XML file that is separate from your layout. So this further removes the layout information from the views and allows you to then control multiple sets of states within a separate XML file. And the way it works is you have constraint sets, and that's constraint sets from 1.1 that you can now animate between those constraint sets. So if you were used to working with constraint sets, you can now use them in a similar way inside of the motion layout system. And what we do provide is a lot of controls, and we'll go through a lot of them here, a lot of controls between, when you're doing that animation between the constraint sets, how do you do them? So the key concepts here are that you have two states represented by constraint sets, A and B in this case. And then you have a transition which takes you between those two states. You can manipulate those transitions with keyframes, and that transition might go straight normally, but you can distort it. The distortions, when they're with respect to position, occur in one of three coordinate systems. A parent relative, a delta relative, and a path relative. And we've had other talks about this stuff.
Yeah, I mean, I would add that's actually one big difference between constraint layout, motion layout, and other animation system is that the animation basically is going to adapt to, for example, your screen sizes, where we are not doing the equivalent of an absolute layout. We are doing something that's going to be flexible.
Yeah, because since the starting and ending state are in constraint sets, they get laid out by the rules of what's the size of your screen and what's the text and all that sort of stuff. So the animation has to map to that. So you're going from one point to another point. And then we provide some features associated with on-swipe and on-click to be able to drive the animation. The on-swipe is particularly powerful, and we'll have a little bit more about new features in there soon, later. So essentially, we have two files now, your layout file and your motion scene file. The layout file has a motion layout in it, and it's pointing to the motion scene file. In the motion scene file, you'll have constraint sets, and you'll have transitions, and transitions can contain keyframes and directions about on-swipes. And you can have multiple constraint sets, you can have multiple transitions, all defined by IDs.
So let me just go through a very basic example so you get maybe a better idea of how everything works together. So let's say that I have this sun that goes from the start to the end, and it's great, but I want a little more interesting stuff on my animation. So I can specify with a key position a keyframe that's going to basically just, why is my stuff not starting?
They're not starting.
All right. Sorry. What animation not starting, but essentially you can basically create, oh no, it's starting. So you get the idea. I can specify the start and the end, but I can add a keyframe to perturbate, to modify this path. It's not a direct linear path. I can have this nice arc motion simply by adding the correct keyframe. The other thing that's interesting and a bit different than other system is that we are not purely looking at animating the positions. We can animate other type of attributes. Because in fact, a lot of the time for an animation, you want more than just the position. For example, if I want to set up a color change, and not working again, that's interesting. I'm not sure what's going on. Keynote is not happy. Well, let me try again, but otherwise we'll move on. Okay, so you get no idea what's going on with Keynote, but you can see here that by specifying a custom attribute, I can play on the color itself. And we found out that it's very common in animation, right? You don't do only positioning. You can do a lot of things. What it does internally is it basically do a call by reflection to a setter. So as long as you provide the correct type of attributes you want to play with, you can animate your own components very easily. And finally, and it's not working again, but you have cycle that we're going to cover a little more anyway, to add a little more interesting animations. Briefly, how do you use MotionLayout? Because we've talked about this thing, it's a new system, it's a subclass of ConstraintLayout. Does that mean that you have to convert your entire application to this new thing? Well, not quite, right? You can basically use MotionLayout in your existing architecture, in your existing UI. So for instance, if you have a coordinator layout and you want to have a more interesting collapsible toolbar, instead of doing it by hand like you're doing right now, you can use, for the collapsible toolbar, a motion layout. And that will animate that toolbar. All those examples are on the GitHub repository that we set up that contains a ton of examples about constraint layout and motion layout. So please check it out. But it's very, very easy. And trivial to integrate. Same thing if you have a drawer layout and you don't want to use the default style for your menu, you can just create a menu in MotionLayout and go crazy on the animation. Or if you have a view pager and you want to do something more interesting, you get the idea. But the general gist is that you don't have to switch to the new thing 100%. You can gradually integrate it into your application.
So one of the things that you can do is create a custom animation. In this case, Nicolas wrote this interesting little animation, and then the MotionLayout can drive that animation. So this touch response and the rest of the animation is being done by MotionLayout, but that's a custom view that is doing that wrapped around look. That's kind of a very powerful situation where you want to have something unique, some sort of signature action within your system. This allows you to have that. The other thing you can do is nest motion layouts. So you don't, even though we like flat, but sometimes you might have one thing and then you want to have that be reused in several places. In this case, we want to build a coordinator layout like look, and we already built it top, but we want to now do everything in MotionLayout. So now you can have a MotionLayout inside a MotionLayout, and the whole thing would work just fine. Here's an example written by Chris Bain, one of Google developers. And I really liked this one when he put it out because it really is showing that carefully coordinated views. And if we zoom in, you can sort of see that he's tilting. Wait, let's try guessing as to, let's see. Keynote is struggling with, maybe we have a lot of animations.
Maybe next year we'll come up with a MotionLayout, presentation.
Yeah, but you can sort of see it. It's a, if I go to the, yeah, here it goes. If I go, you can see
animation is hard, okay? So
he's tilting it to sweep it, and he has custom views fading and drifting to the left. So there's just a lot of different interactions he's doing in this one animation. And he did this without our help or just by himself. And you can sort of see it's much more difficult than you would ever try to pull off writing it by hand. It's just too many different things in motion.
And again, this is all specified purely in XML. So it's both very easy to play with and test new ideas. And basically what we provide with MotionLayout, the same way as with ConstraintLayout, we try to provide a vocabulary to express layout. With MotionLayout, we try to provide a vocabulary to express motion and to be as powerful as possible.
So one of the things I wanted to talk a little bit more in detail about, because we haven't talked about it much before, is cycles and how they work and how they interact. In this simple example, all of these are all just done with cycles, and you can see the various kinds of interactions and motions all being done, and I just did a random collection of things here. And in fact, you can get fairly sophisticated with your cycles if you wanted. This I do not recommend. But so how does it work? First, everything in a cycle, all the values you see in a key cycle get interpolated over time. And they produce, they're all done with monotonic splines, and that's for a particular reason. If you look at a regular spline, it likes to overshoot. So the blue line is a regular spline. It wants to overshoot for those points. But when you're doing an animation, the kind of thing that we think about, what you want is the green curve. And that's why I chose monotonic splines for this particular purpose. Now, we interpolate using something called a period. We do an offset. We do any attributes you want. And the period in a key cycle works in a slightly unusual way because what you're doing is you're interpolating the frequency response across time in a fairly complicated, the math is hard to explain. But essentially, if we have a key cycle, and you can see it in this graphic, it's going to oscillate in time. But if you change the period, with a period of 1 for the blue dot, you see 1 bump. With 2, you'll see 2 bumps. With 3, you'll see 3 bumps. So it's fairly intuitive. If you want it to shake 3 times, you're putting a period of 3 in the middle. And the frequency is evening out because the period at the starting and then the ending are 0. So the value, if you change the value of something, you're effectively changing the waveform, the envelope of it. So if you have, let's say you're using it to control something like its translation X, the scale of the translation X is being adjusted, so you can make it vibrate and then collapse. If you use key cycles offset, you can distort the envelope in different ways. And now all of these can be combined in very powerful ways. One other attribute is wave shape. That's essentially normally a sine wave, but you can have square waves, and there's quite a few different waveforms you can go through. Triangle waves. Now let's give you one example where we have a cosine wave. If you think about your old math, a circle is really a sine and a cosine, sine of x and cosine of y, or something like that. So if you create a cycle in x and a cycle in y, and you make one a sine wave and the other a cosine wave, you get a circle. And you could do things like spiral it out or spiral it in, all using the key cycles. So there are a very wide range. You can change the frequency. Since there are all these parameters you can play with, you can have various subtle effects in time. And one of the things I know, developers are not used to working with animation that much, so it's a little bit hard to get to understand these concepts. And in fact, anything you want, you can build. Here I built some. The top one is sort of a brick falling down the stairs, and the other one is sort of taking off and flying and landing. So you can kind of come up with crazy, and you see I'm just using a combination of rotation, translation Y, on an overall motion. So to help you with these, I built a piece of software for this, something called Cycle Editor, and we put it out in GitHub along with the motion demos. You can find it there. It's just a pure Java. The source code is there. So it actually contains a lot of the pieces of the internal engines of the motion editor, just separated out and packaged in a way that you can explore how it looks in code, how you interact, and you can change different parameters. Now, time cycles work a little bit different from position cycles. Time cycles, the period is now in hertz. It's literally going to oscillate in time. Very different. So if you look at an animation, the frequency is independent of position. You can stop in the middle, and if you said 5 hertz, it's going to shake 5 times a second. So it's a very different kind of animation. And you can think about it internally. If I move to a certain point and stop, without a time cycle, the animation stops at that point. It's just resting. At this point, in this case, the animation is still going with the time cycle. And all the attributes work pretty much the same way as you're used to it from the other one. So key positions will work. The various kinds of changing values for attribute X in this particular case. You can manipulate the offsets. So all the parameters you used in key cycles, key time cycles apply.
And just to, yeah, it's not because we add that you have to use it either, right? So again, same thing for constraint layout versus linear layout. Hey, if you are happy with just specifying a path with a keyframe position, and it's simpler, that's great. But cycle is here to capture all those, oscillation behaviors that otherwise would actually be very painful to create by hand.
And one of the things to think about here is we're providing a lot of depth of capability in the system so that when you do something simple, if they ask for something more complicated, we have enough depth that you can dig up on how to do a key cycle and figure out how to make it work or something like that.
And so if you haven't tried already, I really encourage you to go to the GitHub repository, check out this small swing application and play with it. Because I think a lot of it is if you play with the app and you see how it behaves, it will be a lot easier to understand than even us showing you those animations. All right, let's very quickly cover what we released in the last few months. We did an Alpha 3 in December. Important to note, there is a new XML format that's actually a bit better and makes things faster to write, we think. The time cycle, key trigger, that's something that can be triggered on the path. In Alpha 4, we added more complex, more rich behaviors for on-click actions, addition to custom attributes, etc., etc. Important stuff, the attributes rename. We had to rename a few attributes, so check out the release notes, but you might have to modify your XML files. And finally, Alpha 5, that we have not released yesterday like we wanted, but we promise it's going to come soon. In Alpha 5, we have a few new features that we're going to cover very, very quickly now because we're running out of time. And that is target matching.
Yeah. So the first feature is when you do a animation, you tend to end up with lots and lots of attributes, keyframes applying to a lot of different views. So in this particular example, you have 9 views that more or less have to have the same attributes. So the way this works is you tag all the views with this attribute. In this case, you set row 1, row 2, row 3, action row 1, action row 2. You could also tag it in the constraint set rather than tagging it inside of the layout file. And that's really your choice as to where and how you view things. But once you've tagged them, you can then, in your key position and key attributes, you can say, apply this to all those labeled action row 1. Or you can use a regular expression, all those that are row star, essentially. So another feature that's coming in this release is region swiping. So normally, you use these three attributes, and they are essentially controlling the animation that is when you're swiping on any part of the screen. So it's essentially a motion across the entire screen. The anchor just helps direct the rate of animation such that it looks and acts as if your finger is pushing that particular object. But with region ID, you can specify a region, and quite often you'll actually have the same region as the anchor ID. And to limit your entire animation, your down point of your touch animation to that region. That can lead to some fairly powerful things because now you can have multiple regions on the screen, and when you touch one, it interacts in one way, and when you touch on another one, it transfers to another state. So it gives you a lot of control and UI. Another simple one, just one tag, is auto transitions. So normally, when you create a transition, you'll have to drive it by hand. But with auto transition, you're kind of saying, now just automatically animate to the start or the end or whichever direction. So once it's in one of those states, it will automatically fire the transition to the other state. So what could you do with it? So for instance, if you wanted an on-start animation, and you can have that fly in, and then it will interact with the screen. And the way that would work is you have your normal transition, A to B, but you create this pre-roll, you can think of it as animation state, and an auto transition into animation 8. As soon as it starts up in the start state, then it'll automatically animate to the state A because you've configured that. And in fact, you can have it jump to start, jump to end, animate to start, animate to end. It's fairly subtle what you can do with this, and as you sort of encounter a need, it'll be useful. Now, one of the things that has been happening is you're creating lots and lots of different constraint sets. We added one feature, which is the ability to say, here's a constraint set, it's based on this other constraint set in this file, so that you can have sort of stacks of constraint sets. You can start off with one that's empty, and it just really means whatever in the layout file. But then you can add another one which is based on the base plus a little bit of stuff, because that's what its default behavior up to now is. But now you can add this derived constraint from, and so it's taking the state 1 state and adding something to it. Now remember, constraint set represents the entire state. It's not a change. This is just allowing you to dynamically build up that state in the file. And then in the final one, we've just stacked a whole bunch of them. And I've stacked them as much as 8.
So we'll be super quick about virtual layout. But again, this is basically to position essentially think about it as something to help you create the constraint for you. And the one we're introducing in Alpha 5 is called Flow. It supports multiple type of layouts. The simple one is essentially applying a chain, either horizontal or vertical chain. But we have a couple more things. It's also a view. So anything you can do with a view, you can do it. So setting a background, etc., etc. Setting up the position of the view as you want is the same way as any other view. For chains, we support all the type of chains. So nothing special here. This is how you specify it in XML. You have those new attributes for flow. And now the interesting thing is if you actually run out of space, right? What do you do? Well, in that case, we allow you to set up a wrapping behavior. The default one is simply going to create 2 chains, or in that case, but essentially as many chains as necessary. You can actually specify one type of chain for the first chain and different type of chain for the rest of the elements. Specify the max number of elements. So that looks cool, right? Maybe like a table. Other than the fact that because it's a chain, if one of the elements is not the same size, it's not going to look like a table, which is where the third layout mode comes in, that essentially gives you a table-like behavior. So how to use that in a basic layout, typical calculator example, right? So you basically position that as a normal view, just centered in the parent. The thing that's, here, very, very typical stuff, constraint layout. And here you got those specific attributes that drives how the layout of those reference elements is going to be done. And you end up with this. But what's nice is because it's just a normal view in the system, you can, here I'm just creating another text view that's going to be placed relative to that one, and I can simply reference it, no problems. But even nicer, I can do the same for the elements that are inside the virtual layout, because we are actually completely flat still. And that works beautifully with MotionLayout. If Keynote wants to start. Yes. So here, on the fly, I change basically the orientation of the virtual layout, and everything works well. And because it's not actually a container, you can see that this first magenta tile is pulled out of the virtual layout, because in that second state, I simply do not reference it. And I decide to apply different type of constraints. I had something about recycler view, but we'll go too fast. But essentially, this is coming. So to make the whole recycler view stuff a little nicer on how to integrate with MotionLayout. And I'd say the only thing important here is you can have the basic behavior of I'm going from that recycler view state and going to some other states. But what's nice is because we got all the primitives that we're using to specify motion, it's super easy to tweak that motion to something more interesting. So here I'm just adding a size delay, or here I'm just adding a tilt effect when I pull that card. And that's the thing that's really nice. Now that the animation is set up, it's trivial to play with it. All right, wrapping up quickly, we announced Alpha 4 April 4th. Alpha 5 will try to release it this week. Beta 1 around Google I.O. and Motion Editor after Google I.O. There's a bunch of documentation online already. And we even recently updated the DAC docs. Check out the GitHub, lots of interesting stuff. Give us feedback, issue tracker, please file bug, feature requests, and etc. Tomorrow there is an office hour as well. Don't hesitate to reach out to us either in person here or online. And thank you very much.